When you look at this, what do you see? A fortress from another planet? A secret military base hidden from the world? Not quite. This is Daxing International Airport, China's aviation megastructure spanning over 1 million square meters, enough to swallow 97 football fields. But what truly stunned the world wasn't just its size or futuristic shape, it was the speed. Daxing was completed in less than 4 years, nearly twice as fast as Changi Airport, which is the world's best airport in Singapore. What technology did they use? And does this bizarre, star-shaped architecture hold any deeper mystery, or is it simply an artistic creation? In this video, massive minds will take you beneath the surface into the engineering systems, construction strategies, and design philosophies that made Daxing not just an airport, but a national symbol of rising power and ambition. 2016, in Beijing, China. The sky is heavy, but the real crisis isn't the smog, it's the gridlock in the sky. At Capital International Airport, the system has hit a breaking point. 1,200 flights delayed, passengers sleeping on terminal floors. This wasn't a weather delay, it was the sound of a superpower's infrastructure grinding to a halt. This wasn't just overcapacity, it was a structure. A nation of 1.4 billion had its ambitions held back by a single choke point. The ripple effects were severe, including disrupted logistics chains, delayed foreign investment, and a decline in global competitiveness. So the question emerged, what would China do when the beating heart of its transportation system began to fail? Rebuild a new airport, Beijing Daxing, a technological heart engineered to pump new life into an accelerating economy. It was more than an airport. It was a strategic move, a make-or-break decision that would shape China's role in the next era of global power. On a tense morning in January 2017, as Beijing Capital Airport strained under unbearable pressure, China's National Development and Reform Commission made a historic decision. Rather than expanding what already existed, China would reinvent its entire aviation system. No additional terminals, no new runways. Instead, a next-generation airport would be created to operate as a vast logistics hub, pre-programmed to serve the next 50 years. But how can a massive superstructure, which sits atop the North China Seismic Belt, a zone once rocked by magnitude 8 earthquakes, conventional wisdom would suggest a deep foundation, hundreds of piles driven into the earth, but that only shields against gravity and wind, not the violent horizontal shear of an earthquake rising from below. So engineers turned to a radical solution, one usually reserved for nuclear reactors or military command centers: the base isolated foundation. At its core, 1,152 seismic dampers, built like rubber steel sandwiches, were inserted between the structural columns and the terminal's main floor. These isolators allowed the entire building to glide a few centimeters in sync with seismic waves, dissipating energy without passing it upward into the structure. In other words, instead of resisting the quake, the terminal would move with it in perfect coordination. This significantly reduced stress concentration and prevented structural cracks. This was not a theory. It was a tested and proven method. Moreover, pouring over 1.6 million cubic meters of concrete, equal to 7 times the volume of the Roman Colosseum, demanded a massive logistics operation. More than 100 construction teams, 24 mixing stations, and thousands of concrete trucks had to work in absolute sync. A single delay, temperature shift, or extended wait time could cause bonding failure. This required near-perfect coordination across materials, equipment, workforce, and timing. Unlike conventional projects where segments are poured and tested step by step, Daxing's critical structures were cast in continuous closed-loop cycles. How do you support a roof that weighs over 52,000 tons, equivalent to 14 Eiffel Towers, using just 8 columns? It's just 8 columns. Yes, only 8. You heard that right. Why would engineers concentrate such immense pressure onto so few load-bearing points? Was it a reckless move, especially for a structure expected to stand for generations, or even withstand the unimaginable? The answer isn't about saving materials or subjective. It's about design, boldness, and intellectual thinking. Each of the columns at Beijing Daxing International Airport is a structural masterpiece, not cast as a monolithic unit, but assembled in layers, like a high-precision sculpture. The construction process began with a deep foundation pile system, carefully drilled and reinforced to withstand vertical compression and seismic shear. Each column base was anchored on steel-reinforced concrete cores, reaching dozens of meters into the ground, ensuring they could bear thousands of tons without shifting even a millimeter. Above ground, the columns were built using prefabricated steel segments, each pre-cut in the factory to millimeter-level accuracy using industrial laser systems. These steel segments were shaped into C-shaped sections, not solid cylinders, but partial enclosures with an open inner core. Why this shape? Because it performs multiple tasks at once. It distributes structural load evenly, reduces weight, resists torsional stress, and creates a hollow shaft, a technical void for ventilation, lighting, and even sensor routing. During assembly, the steel segments were lifted by crawler cranes in sequence, then robotically welded on site with real-time temperature monitoring to avoid thermal expansion cracks. Each weld was inspected by X-ray to ensure absolute integrity. The outer scale-like skin made of reflective aluminum panels was then mounted onto the C-frame using hidden fasteners, giving the columns a seamless, aerodynamic finish. Internally, each column was engineered as a vertical, light pipe, directing sunlight from rooftop apertures down to the lowest underground levels. This design eliminated the need for bulky skylights and allowed natural illumination across nearly 1 million square meters of interior space. In essence, each column is more than a load-bearing structure. It is an integrated system foundation, frame, facade, and daylight conduit rolled into one intelligent unit. This wasn't just about holding up a roof. It was about holding up an idea that less can be more, that strength can come from precision, and that bold vision, when executed flawlessly, doesn't need backup. So what do you think? Would you stake a multi-billion-dollar structure on just 8 columns? Would you trust it? Let us know in the comments below. Massive minds would love to hear your thoughts. If the pillars are the skeleton, then the dome is the skin. Not only shelter, but also tells a nationally recognized story. From satellite view, Daxing Airport doesn't resemble any airport ever built. It's not a conventional box or a modern glass cube. It looks like a 5-pointed star reaching outwards in the shape of a phoenix, the mythical Chinese symbol of rebirth, immortality, and rising from the ashes. This was not a mere artistic flourish. It was a decision rooted in logic. Each wing represents a directional flow: people, cargo, energy, security, and logistics. The center is the heart. The arms are arteries. Gone are the endless, soulless corridors. Instead, Daxing operates as a living system of dynamic symmetry, where no passenger needs to walk more than 600 meters from the center to reach their gate. But this leads to a more difficult question: how to construct a massive dome weighing over 52,000 tons while still maintaining a sense of solidity and elegance. No, China's engineers delivered an answer that rivaled and arguably surpassed anything built by the West. They revived a construction philosophy from ancient Chinese civilization and applied it to the roof of a 21st century national landmark. It's called the yin-yang tiling technique, a principle thousands of years old. Nearly 100,000 aluminum-clad steel panels were CNC cut with millimeter precision and layered like fish scales. These tiles simultaneously deflect typhoon-grade winds, self-drain rainwater, and reflect solar radiation to reduce internal heat buildup. And beneath this skin lies an invisible masterpiece, a 3D steel mesh shaped like a giant honeycomb, assembled at over 40 meters high by robotic welders with a precision margin of under 5 millimeters. All of it, every bolt, every curve, was pre-designed, manufactured in factory conditions, and assembled on site like an industrial puzzle on a planetary scale. This is not traditional construction. It is the transformation of the construction site into a digital assembly line where engineers are programmers, workers are robotic operators, and the airport becomes a physical expression of algorithmic precision. From afar, the star-shaped roof is a symbol. But up close, it is a manifesto that in this century, nothing is built by chance. Every detail must serve performance, efficiency, and national sustainability goals. This is not just steel in the sky. It is a philosophy: maximize usable space, minimize energy waste, and let identity flow through form. If the roof is symbolic, beneath it lies intelligence. With world-leading advanced digital technology, the entire Daxing Airport is operated by hundreds of artificial brains in a high-speed, circulating information ecosystem, where every operational decision is processed within milliseconds. Hidden beneath the concrete and steel are over 50,000 sensors, installed throughout the building from corridors and restrooms to escalators and even handrails. Each sensor collects billions of signals daily: temperature, humidity, crowd flow, speed, and even floor pressure levels. All are sent to the big data center, the true heart of the operating system. Crowds start piling up at security checkpoints? No reporting required. The system automatically activates alternative traffic flow, opens additional gates, adjusts elevators, and even alters internal train schedules to reduce pressure in that area. All this happens silently, without warning lights, loudspeakers, or commands. The system not only processes, but also learns. Every day, deep learning algorithms automatically analyze passenger behavior, including popular routes, average stop times in each area, and energy consumption rates at different times. From this, the operational map is updated, refined, and reprogrammed for higher efficiency the next day. More importantly, all the technology is hidden. No flashing screens, no tangled wires. Everything is integrated into invisible infrastructure layers. Clean, minimalist, and seamless. This is no longer just an airport, but a smart city on a compact scale, where every action is predictable and every bottleneck has a contingency plan. This is when the aviation industry needs not just more powerful engines, but smarter brains. We can all see the Grand Dome, the vast departure halls stretching across hundreds of thousands of square meters, and the record-breaking 4-year construction timeline. But what remains hidden is the true secret behind this seamless, rapid, and efficient achievement. It wasn't just manpower. It was the invisible current of logistics flowing beneath the towering concrete and steel. An airport may be beautiful, may be monumental, but to build it at such extraordinary speed, every material from steel bars and bricks to cables and electronic systems had to arrive at precisely the right location, at precisely the right moment. Not too early, not too late, but how? Daxing solved this challenge with an unconventional logistics system, transforming the construction site itself into a massive industrial engine. Concrete plants, asphalt mixing stations, and steel workshops were built within the site, cutting down the entire supply chain from several days to just a few hours. Over 200,000 tons of materials were processed each week. And every single hour, up to 1,500 workers, engineers, and machines were mobilized through an internal roadway network where trucks were never allowed to stop, and each minute of delay could mean millions of dollars in added cost. This was no longer traditional construction. It was a full-scale military-grade operation with zoning maps for every sector, hour-by-hour schedules, and minute-level execution. All of it is supported by building information modeling, a digital system enabling real-time coordination of every resource across the entire site. And when you finally walk through this airport, you will see no trace of the chaos that usually comes with construction. Because here, disorder was never allowed to exist. It had already been programmed out from the very beginning. In many ways, an airport marks both the beginning and the end of a journey. But for Daxing, it is not just a destination. It is a statement about the future. In just 4 years, what people built was not only a massive structure, but also a philosophy. That speed means nothing without precision, that volume cannot exist without minimalist thinking, and that technology has no power unless it serves human needs. Seen from above, the star-shaped roof is not merely the symbol of an airport. It is a miniature image of an economy reaching outward to the world from the heart of the nation. This is a structure built not in the middle of nature, but at the crossroads of history and the future. And perhaps what makes it truly extraordinary is not its size, but the vision that gave rise to it. What do you think? In a world that changes every single day, could your city learn something from how others are building their future? Leave your thoughts in the comments below. And if you believe that engineering is not just about machines, but about how humanity dares to reach its dreams, Subscribe to Massive Minds and join us in discovering the world's greatest projects reshaping our planet.